Hi everyone, today we are here with a new problem and the problem name is network delay time. Okay, now we see what is the problem and how we can solve it. It is a medium type of problem. Okay, so in this problem basically we have n nodes and the nodes is from 1 to n, and we also have an array which is times. This array at an index, this array tells the source in the source node, the destination node, and the time required to send signal from source node to destination node, right? So what we actually have to do, initially we have a we are pointing at some given node k. Okay, so we are pointing at some given node k, and from that node we have to send signal to all the nodes of the connected nodes. Okay, and we have to tell how much time it will require to send signal to all the nodes. If it is possible to send signal to all the nodes, we have to return the time, and if it is not possible, we have to return -1. Let's understand this with the help of one example. Okay, now you can see in that case we have this as an array, and what it says, source node is 2, destination node is 1. So from 2 to 1 it will take 1 second to send signal. Similarly from 2 to 3 it takes 1 second, 3 to 4 it will take 1 second, and we have total 4 nodes, and what we have actually a 2, k equal to 2, which means we are in starting we are present at this node. So how much time it will take? So you can see that it will take 1 second here, 1 second here. So in the 1 second signal reach to 1 and the 3 node, and in the another 1 second signal reach to 4th node. So in total we have 2 seconds required, such that we will send all the signal to all the nodes, right? And similarly if you see this, right, it is 2 actually. So if you see this graph, so and initially we are at the one node, this node. So first signal is go there, and it will take 2 seconds here, right? So in such way it requires around 3 seconds to send the signal to each node. So here the answer is 3. Now from this you can understand it is a graph problem, right? In graph we basically have such type of nodes and some weight, and these are the things whenever there are some graph problems. Now the thing is how we are going to solve this. So basically in that problem you can see what are the things here. So here basically we have a node, we are at some node, and we have to send signals to all the nodes, okay, and we have to find the time, how much time it will require, such that we will send the signal to all the nodes. In that case most probably we are using the Dijkstra's algorithm. Okay, so this algorithm is very important algorithm in graph, and in order to understand this I will give you a small small understanding of Dijkstra's algorithm, what we are doing in the Dijkstra's algorithm. So basically in the Dijkstra's algorithm we have nodes, and all that nodes are connected by some path. Okay, so let's suppose there are some nodes. Let's suppose this is a node, and these nodes are connected by some path, as you can see. Okay, now Dijkstra's algorithm tells, let's suppose we are at this node and we have to traverse all the nodes. So Dijkstra's algorithm help us to find the smallest path or the smallest time or minimum cost, such that we traverse all that nodes. Okay, now how we are doing in the Dijkstra's algorithm. Okay, for that I will create a separate video, but for now you can understand, like, let's suppose we are at any node. So this node is connected to, let's suppose, 3 node, this node, this node, and this node, right? So initially what we do, we basically take or follow that path where the cost to reach from one node to another node is less. Okay, so basically there are two things in the Dijkstra's algorithm. The first thing is to move from node 1 to let's suppose this node 1 is connected to node 2, node 3, and node 4. So what we do basically, we basically find, to travel from node 1 to all these nodes, which node cost less. This is the first thing we do. Okay, and the other thing is we try to detect the cycle. Okay, What do you mean by this detect cycle? So let's suppose this is one node, this is another node, okay, and there is also and I will give you an example. So let's suppose this node is connected with this node, right, and this node is connected with this node already. Now let's suppose from there I will create one more node. So you can see there is a cycle. This node, this one node is already connected through this node. In that case we don't have to add any extra path because it also cost, right, and we have to reduce that cost. So discussed algorithm follows that thing too, okay. So this is the way how we are going to solve this problem using the discussed algorithm. So the first thing here is, let's suppose we are at some node and this node is connected with three other nodes. So we need to find the minimum cost. For that, to find the minimum cost, we actually use heap. Okay, what we do, let's understand this through an example such that we can understand how we are solving it. Let me rub all of these things and see how we are solving this. So initially you can see that we are at the node 2. So in our heap, I hope you already know about heap. So in our heap we say that we are at the node 2 and this 0 specifies the time required, okay. So as you know we are at the node 2, so there is no such time requirement, right. So what we do, we will pop this from the heap, which is 2, and now we will check this 2 is connected with which of the other node, okay, which is 1 and which is 3, and we will push these two node inside the heap, okay. And also one more thing, in order to detect the cycle we are using a visited array, and this array tells which node is already visited and which node is not visited. So basically we are there, we have four nodes, so we can take an array 1, 2, 3 and 4, and now you can see the second node is visited, so it is true, other than that everything is false. Great. Now initially we are at node 2 and time requirement is 0, got it, and this 2 is connected with 1 and 3. So when we travel from 2 to 1, so the time is 0 plus 1, so we will add this like that, time is 1 and the node is 1. Similarly, to move from 2 to 3 the time required is 1 second, so what we do, we will add 1 and node is 3, right. We will do this process until our heap is empty, okay, not empty. Now we will remove that node having less time required, okay. So what we want that node from 2 where we need less time to move. So you know 2 to 1 it also take 1 second, 2 to 3 it also take 1 second, so we can remove anything. So we will remove this, which is 1 and 1, so the node is 1 and it is also visited, so we make it true. Great. And after make it true, what we do, we will check for this one, is this one is connected with any other node. You can see this one is not connected to any other node, so we will cancel that out. Now there is only one node remaining in the heap, so we will remove this. So this is 1 and 3. Now we will check from 3, is there any node connected? Yes, 4. So from 3 to 4 how much time it required? So 1 is already there, so from 2 to 3 it will take 1 second, and from 3 to 4 it will take 1 more second, so it is 2 and the node is 4, and also we visited 3, so we also make it true. After this we will take this node and push inside the heap, so we will write 2 and 4, right. After this we will pop this 2 and 4, So the node is 4, we make it visited, and the time is 2. And when all those nodes are visited, now you can see all these nodes are visited. In that case, whatever the time we get from there, we can return it. Okay, and that is the solution for us. I hope you get this. If not, we can understand the code, and I hope you get more things from there. Okay, the code is similar to this. Okay, two more other things. So this is a matrix. If you solved any graph problem, you know we need a matrix, and that matrix stores what? It stores the source node, the destination node, and what is the time required in order to travel from source to destination node, right? And this is a heap. What it stores? It stores the time required and the node. Initially we are at the kth node, that's why we push k in it, and the time is 0. We also use a set. We can use array, but set is very easy for us, because we can simply add things in set, and we can check when this set length is equal to the total number of node. It means every node is visited, and we can return the time. Now initially we are at the kth point, and we will pop it from the heap. Okay, and this is the node. Now what we do, we simply add it in the visited, such that this node is visited, so we add it in our visited set. And then for that node we will see whatever the nodes connected with this node. So all that node, if it is not visited, what we do, we will add it in the heap. This is the time required to move from this node to this destination node, which is the time plus time required, and this is the destination node, and we will push all these things inside the heap. For the next time, heap pop will give that node having less time required. Okay, that node is move out from this heap, and we will also make it visited, and this process goes on until and unless we will visit all the nodes. If we are not able to visit all the node, what it means, let me take a very simple example. Let's suppose n equal to 4, and we have 1, 2, 3 and 4, and this 2 is connected with this 2 is connected with this, but k is equal to the 1. In that case you can see that 1 is not connected with anything, so we are not able to even send this signal. In that case we are not able to add all these nodes inside the heap, and we are not able to visit all these nodes, and thus we have to return -1, right? And I hope you got this, and if you want to understand discussed algorithm, you can comment, and I will surely create one video for you. And thank you.